In last week's video, we introduced Moshe Shafty's original and revised plans for Habitat 67, conducted a site analysis of Habitat 67, and discussed file foundation and map foundation. Starting today and for the next 2 weeks, we will be studying the core and essence of Habitat 67, modular construction. Based on knowledge gain, we will produce a video explaining how various types of modules are combined to form Habitat 67, commencing with the foundation unit, the single module. As mentioned just before this week, we will take an overall look at the production process of smallest unit that comprised Habitat 67, the module. We will investigate where the module used in Habitat 67 were produced, the cost-benefit analysis based on the distance between the module production site and the construction site of Habitat 67. Structural analysis of load-bearing structure of modules using precast concrete, and installation of various wiring and facility for actual occupant of these modules, and why such installations were carried out in the manner they were. Our modules used in the construction of Habitat 67 were manufactured at tennis court located in Sept-Îles on St. Lawrence River, Montreal, Quebec, Canada, where Habitat 67 currently stands. Typically, modern modular construction involves manufacturing modules in factory and transporting them to construction site for assembly. However, at the time of Habitat 67's construction, the concept of modular construction was not fully established, and even if it were, the infrastructure for producing modules in Montreal, Quebec, Canada was not properly established. Therefore, the modules used in the construction of Habitat 67 were produced at the tennis court in Sept-Îles, located just 300 meters away from the Habitat 67. Due to the lack of proper infrastructure for module production, concrete modules were produced on-site, right next to the construction site. However, this turned out to be highly efficient. As mentioned in previous video, Habitat 67 faced initial financial challenges, leading to reduction in the scale of construction. The on-site production of modules had further reduced construction costs, which were already strained due to the limited budget. However, it may be difficult to grasp the effectiveness of module production method for Habitat 67's construction based on the explanation provided so far. Therefore, using CMP technique, we will provide additional explanation on how effective Habitat 67's module production method was. The CMP technique was developed by American company DuPont in the 1950s. It is used to estimate the shortest construction period and cost by considering overlapping process throughout the entire construction process. It comprehensively reviews various factors such as construction duration, potential areas of defect, and quality based on different percentages. The percentages shown in table represent the proportion of module factory process in overall construction process, and the associated time and cost are qualified relative to these percentages. For example, in the case of Habitat 67, if the module factory process accounts for 80% of overall construction process, then only foundation work and module placement are done on site, while various equipment installation within the module, finishing work, and loop assembly are all completed in the factory. If it's 50%, on-site activities include foundation work, equipment installation within the module, finishing works, and loop assembly, while the factory only produced the module structure. Looking at the table for construction duration, it is evident that when the process at the module factory constitutes 80% of overall construction process, the total construction duration is drastically reduced to 62% of the total construction duration, when it constitutes 50%. This indicates a significant reduction in construction period. Similarly, in terms of construction cost, it can be observed that while the 80% scenario incurs slightly less cost compared to 50% scenario, the difference is minimal. So far, we've examined where the modules used in the construction of Habitat 67 were produced and the efficiency difference in construction duration and cost based on the proportion of module factory process in the overall construction process using the CMP technique. Now let's dive into the most fundamental module of Habitat 67. There is only one type of unit module used in Habitat 67, and a total of 354 identical unit modules are combined in groups of 2, 3, 4, or 5 to form a total of 158 dwellings. Details on how modules are combined to form dwellings and the overall modular structure of Habitat 67 will be covered in the next 2 weeks video. Today, we will focus on exploring the fundamental unit module of Habitat 67. A unit module made of concrete with comprehensive strength of 35 MPa, has dimensions of 5.18 meters x 11.58 meters x 3 meters. Each unit module weighs close to 90 tons. To manufacture one unit module, it required $44,000. This unit module creation process for Habitat 67 follows a systemic procedure to ensure the quality and integrity of each module. It begins with the preparation of aggregate materials, including sand, gravel, and crushed stone, which are essential components of concrete mixture. Once the aggregates are ready, they are combined with the cement and water to create concrete mixture, ensuring a uniform blend of materials. Steel reinforcement bars or levers are then carefully arranged within the formwork to provide structural strength to the module. Once the formwork is prepared, the concrete mixture is transported to casting area and poured into the formwork, taking care to evenly distribute the concrete and fill the mold completely. After pouring, the concrete undergoes a curing process to strengthen and harden. To expedite this process, steam curing is employed, using high-temperature steam to accelerate the hydration reaction of cement. Once the concrete is sufficiently cured, sandblasting was utilized to treat the surface of constructed modules. Typically, concrete surface can accumulate various particle contaminants or corrosion during construction. These impurities can ruin the appearance of modules, and sandblasting is employed to remove them and clean the surface of modules. Sandblasting is performed by forcefully projecting sand or other solid particles onto the surface of the modules using high pressure or compressed air. This process is effective in etching the surface and removing contaminants. Therefore, sandblasting contributes to enhancing the visual quality of Habitat 67 by improving the appearance and cleaning the surface of the modules. After the sandblasting process is done, various components are installed within the module, including electrical wiring, wood flooring, mechanical systems, plumbing fixtures, insulation materials, and window inserts. These components are carefully integrated to ensure functionality and efficiency within the module. Just before the installation of electrical wiring and wood flooring, the post-tensioning method is employed. We will delve into the details of the post-tensioning method in the future video. After various components are installed within the module, prefabricated bathroom units containing fixtures such as sink, toilet, and showers made by Frigidaire Appliance Company are installed into the module as well, along with any necessary plumbing connection. Finally, upon completion of the assembly and installation process, the finished module is lifted and transported to its designated location within the Habitat 67 structure, ready for incorporation into the logic complex. This comprehensive process ensures that each module meets the required standards for strength, functionalities, and aesthetics, contributing to overall success of Habitat 67 project. Throughout today's video, we have explored the production side of the modules used in Habitat 67. The cost-benefit analysis based on the distance between this production site and the construction site of Habitat 67, the structural analysis of modules, and installation of various wiring and facilities for the actual residents of these modules, explaining how and why such installations were carried out. Next week, we will explore how many modules as investigated today were combined and in what manners to form a single dwelling unit. Additionally, we will analyze the load-bearing structure of larger modules created by combining the unit modules, and examine how various wiring and facilities of the fundamental unit modules we explored today were interconnected during the module assembly process. Thank you very much for listening to our Team 7 presentation so far.